Hello everyone, this is going to be my review of the 2024 AMC12A. As with the AMC10A video, I do want to make this last 75 minutes, which is the time limit of the AMC12. That of course means that we are going to go at a pretty fast rate. So just a couple of reminders before we begin. The first is that all of you will be targeting pretty different scores and therefore different numbers of questions, therefore different speeds. So the cutoff for last year at the AIME cutoff was a mere 76.5. You can do your math and see that that requires quite literally less than 10 questions if you include blanks. The distinction cutoff was 108 and the distinguished honor roll was 133.5. Now those are pretty far apart. The implication of this is very simple. We are going to try in this video to cover all the 25 questions in 75 minutes. But depending on what your target is, you may be perfectly happy with something that is approximately 9 to 10 questions. You will be happy if, let's say, about 16 to 17 questions, or you may want to do something about 22 to 23 questions. It is going to completely change your perspective on whether you are in a rush. We will be in a rush in this video. One more remark is that there's quite a lot of overlap with the AMC10A questions. That is by design. The 10 and 12A on the same day have about 10 overlapping questions. So the ones in the front are all basically from the AMC10 as well. You should find them pretty easy regardless. So we are going to speed run them as if we were doing it in contest. I'm not going to explain it in a huge amount of detail. All right, so question 1. Now I'm looking at this and immediately I can tell that there is a 99 repeating, there's a 101 repeating. So I will just split it like this. These two are the same because they are both 101 times 99 with 2 zeros at the back, and 101 minus 99 is 2. Question 2. Fairly wordy problem. But it's question 2, so you should trust that it can't be too hard. I will just put into this equation. A model is just saying an equation that is going to work in somehow all circumstances. Not very realistic, but if I put this in, I get 69 equals to 1.5a plus 800b is also equal to 1.2a plus 1100b. I equate this to, I get 0.3a equals to 300b, so a equals to 1000b. I put that back in, I get 1200b plus 1100b, which is 2300b, so b is 0.03, and a is 30. It then asks me how many minutes for 4.2 miles and 4,000 feet, so 4.2 times a and 4,000 times b would give you 126 plus 120 equals to 246. Okay, so by the way, I've left a copy of the questions in the description below as well, because the questions are in different orders for paper and online and in different time zones. So refer to the copy in the description if you want the questions in this order. You may have seen the questions in a different order if you took it from a different place. That is anti-cheating measure taken by the AMC. So please don't cheat, but also you will not be very successful if you try to memorize the answers since questions are now jumbled up. Okay, question 3. Pretty easy to tell that when you have the least number of 2-digit numbers to get to 2024 and they are not necessarily distinct, you just use a huge stack of 99s. Dividing by 99, I get a remainder of 44, and therefore 20 numbers are not enough, but 21 are enough because I can just use 44 as the 21st number. So answer is 21. Question 4. what is the least value of n such that n factorial is a multiple of 2024? Please be aware of the factorization of the year number. It always comes up in contests, whether the SMO, AMC, or elsewhere. By factorization, I mean the complete prime factorization, but for 2025, you also know it's 45 squared, so know that as well. When we see this, then we immediately know that n factorial must have 23 in it, which means that n is at least 23. And that is the answer, because when n is 23, obviously 23 factorial will have a bunch of things, including 8, 11, and 23 inside. So clearly, that's good enough. Question 5. Least possible positive sum of 3 integers. Note that they are not the least possible sum of the 3 positive integers. The positive is here. So you definitely know that the trick is I should use some negatives. In order for the product to be positive, it still must have 1 plus and 2 minuses. So if I want to do that, I just experiment a little. If let's say, for example, I use 20, no, that's pretty bad, right? I want it to be less. So if I use, let's say, 12, and then 1 and 5, that is 6. But if I use 10, I can get 3, which is better. And if I use anything smaller, that's clearly not going to work, because less than 10 is 6, and 6 minus 2 factors of 10 are going to give you a negative number. So the least possible positive number is 3. Question 6. This is an easy question from an obscure topic. For most of us, vectors is not something that we see in Olympiads too often. So in triangle ABC, angle ABC is 90 degrees and BA equals to BC equals to square root 2. Okay. Now, by Pythagoras, of course, this is 2. And then now I am told that I am putting these points on the hypotenuse that basically divide it up evenly. And I'm asked for the sums of these vectors here. What I will say is that this is question 6. There's a bit of scrambling of questions, but it's still in the first 10. It cannot be too hard. It can be tedious, but you shouldn't assume it's tedious. Look for something nice, and whenever there's a long sum, a very common thing we do is to try to pair them up, which indeed is possible, because if I were to just reflect it around, you can see that this is going to come here. Just by reflection. And so therefore, if I were to add this vector plus this vector, I will end up with this vector of length 2. So every pair sums to this same vector of length 2. I've got 24 pairs of length 2, so it comes back to 24 again. Question 7. A data set with 20 numbers, some of which are 6, has mean 45. That means that the total, usually for any of these average questions we have seen, we know get the total. When the 6s are removed, the data set has mean 66. Well, that makes sense. 6 is small. When you take it out, the average goes up. How many 6s? Let this be x. If I removed 6 times x from the total, and I removed x from 20, the new average is 66. So I can just solve this. 60x is 420 and x is 7. Question 8. you have got 3, 4, 5, 7, 24, 25. And interestingly enough, we are asked for how are they related. Let's draw 3, 4, 5 and just try to see what's going on. So the smaller angle is always the one opposite the smaller side. What I'm wondering is, how is this related to that? This is beta. Now, it is potentially possible for us to go and draw some kinds of cleverly chosen things in here, but I don't think it is that obvious which it is going to be. So better choice would be to use some trigo and try to find a relationship. There are different ways that you can use trigo, so I'm just going to suggest one, right? Because it says in terms of alpha. Now, I know that sine alpha is 3/5, cosine alpha is 4/5. If I look at this here, cosine beta is 24/25. And I can immediately see that, oh, that is very clearly related. It's sine to alpha. Cosine, the cosine stands for complementary. So it means that sine of pi over 2 minus beta equals to sine of 2 alpha. So accordingly, beta is just pi over 2 minus 2 alpha. I'll say that this is a very early, not so easy question. For questions like this, sometimes you see it, sometimes you don't. Please be prepared to skip it first. Now, another trigo question. This one technically includes logs, but in practice, there's barely any logs because it just uses one log identity. And then that tells you that this is 1. And so immediately, I don't need to use any special identities to say that both of these must be 1. Don't sort of second guess yourself. They cannot both be -1 because it's in log, right? So log cannot be of a negative. That's why I know they must both be 1. Sine and cosines are between -1 and 1, but in this case, log of it tells you that it's between 0 and 1. Okay, so sine 3 theta equals to 1. On your unit circle, you know that sine is the thing that comes on top. So it means that it can be 90 degrees and then just add on extra cycles of 360 degrees. Okay, so theta equals to 30, 150, or 270. Meanwhile, your cosine equals to 1 at 0. So this is going to be 0, 360, 720, which means that your theta is 0, 180, 360, and there's no overlap. So the answer is just 0. There are no such angles. Now, pretty hilariously, if you got to question 9 here, which we have taken less than 15 minutes to do, you would already have qualified for the AIME last year. Caveat is that you don't know that in advance. You should definitely not just only target, I will try to solve 9 questions out of 25. However, just please maintain for the AMC12, maintain that sense of, I'm doing okay. Don't panic and say, this is horrible, because look, if you get here, you've gotten the AIME. I should also say that, to be fair, something like question 8 is not the easiest one. So it is much more likely that if you were to get more of these questions, they may come from some of the next 3 or 4. So we will look at those. Question 10 is a classic difference of squares question. I feel that I have an entire worksheet of this just for the SMO Junior, so many of you would have seen this enough times. Just call them both squares, that's literally what you're told, and then subtract off so that you have a difference of squares. Two quick reminders. Number one, you want the greatest integer. So when you want the greatest, x and y should be big, meaning that this should be big and this should be small. Second reminder, y plus x and y minus x must be congruent mod 2. They should have the same parity. So you cannot use 1 and 2560, otherwise y will be 1280.5. It should be 2 and 1280, which would then give you y is 641, x is 639, and thankfully only the last digit is required. So m is congruent to 1 squared minus 3. If I sub into this one, is 8 mod 10. Units, digits, one digit, last digit all mean the same thing. Okay, question 11. The first 3 terms of a geometric sequence. A geometric sequence is the same as a geometric progression. There is a common ratio. There's a common ratio, means that these are equal. They are integers and b is bigger, but you want it to be as small as possible. So you want the smallest possible factor of 720 squared that is still slightly more than 720. I guess that the easiest way to think about it is that I have to do a prime factorization of 720. 720 is divisible by 16. So this is my prime factorization, and I just want to make b a little more. Most of the controls come from the tools, so I'm just going to write down my powers of 2 to take a look. So I'll think of it as, okay, these are my powers of 2. Can I choose something and multiply it by something from here? That's 2025, by the way. A factor of this that will push it just above 720. The answer to that, if we look at just the last one, we already see that 256 times 3 is 768. And there is unfortunately not a very good way, apart from just sort of doing a bit of systematic listing, to see which of these can potentially do better. The answer is you can't do better. 768 is optimal. And so that is going to give you that b has sum of digits 7 plus 6 plus 8 equals to 21. These are the kinds of questions where in the AMC you will tend to be a bit scared. So I would sort of KIV this question, meaning I will do it and say that this is not a hard question, but I'll come back and check it if I have time, because how am I supposed to be so sure that I haven't missed any other factor? I actually don't know. So that is a bit annoying. There isn't a super efficient way to guarantee you haven't missed anything. So therefore, come back and check a bit later. Okay, number 12. The graph of y equals to e to the x plus 1 plus e to the negative x minus 2 has an axis of symmetry, so a line of symmetry. What is the reflection of the point here over this axis? Now, the axis of symmetry, when it says axis, my understanding is horizontal or vertical line. When y is a function of x, of course it cannot be symmetric over a horizontal line, so it must be a vertical line. Therefore, what you can do is just substitute in like some values where you think that it's going to give you the same value of y, because then it means that if this is the line of symmetry, then your points are going to be symmetric about this. E to the x plus 1 and e to the minus x, I'm thinking that if I can swap these two around, That's good. Right? So if let's say, for example, x equals to 1, e squared and e to the minus 1. Now, so if I put x equals to minus 2, then I am likewise going to have e to the minus 1 plus e squared. Yeah, and likewise, if you just put it in general and call this fx, it would be the same if you replaced minus x to become x plus 1. It's just this. These two sum to minus 1, meaning that the line of symmetry is when x is minus half. So minus 1 half is here, you reflect over and you would just end up with 0, 1 half. Okay. 13. There are exactly k positive integers b such that this base b number is divisible by 16. Okay. Base numbers, again, is a topic that is much more common in American contests than in Singapore or Asian contests. The main thing you just need to know is what does it mean. So if you know binary, that's base 2. If you know our normal numbers, that's base 10. Essentially, base b is that 1, your digits must be less than b. Just like binary is base 2, it only has 0 and 1. Number 2, each place value is now a power of b. So this is just 2b cubed, 0b squared, 2b, and 4. So if b is 10, then this is just a normal number. I want this to be divisible by 16. I can just chop off a factor of 2 and say that this must be divisible by 8. One simple option, just check all the all the residues from 0 to 7 mod 8 and just see which ones work. If we want to be a bit more efficient, there's a tiny shortcut, which is that when b is even, b cubed is going to be 0, so b must be congruent to negative 2 or 6 mod 8. And b is odd, b cubed is just congruent to b, so 2b plus 2 is congruent to 0, and b is congruent to 3 or 7 mod 8. Everything here is mod 8. Therefore, 3 out of 8 values are going to work. 2024 is divisible by 8, so I can just first calculate this. And then I remember that I have to exclude 1, 2, 3, 4. There is this number 3, which is disallowed from the range. So 7, 5, 8, because exclude b equals to 3, sum of digits is 20. So far so good, right? As you can tell, when we are doing these sorts of questions here, I am telling you every possible shortcut that I can think of, but there is always a normal way to do it. Now, if you were doing this with the intention of getting, let's say, a distinction, then you don't need to do it so fast. Only if you're trying to get a DHR, meaning almost finish the paper, then every shortcut that you can possibly find, you want to do that to save yourself some calculation time. Okay, question 14. A set of 12 tokens, 3 red, 2 white, 1 blue, 6 black, is distributed at random to 3 game players, 4 tokens per player. The probability that someone gets all the red tokens, another one gets all the white tokens, and the remaining player gets the blue token. The black ones are therefore just like kind of like placeholders, right? So let's name the 3 players A, B, and C. Now the sum player, the sum player, another player, and remaining player, every combination of, let's say, maybe this is A, maybe this is B, maybe this is C. There are 3 factorial different orderings that clearly are equally likely. So I'm going to just take 3 factorial, and then now I'll find the probability that it goes like this. Okay, so this is now going to be followed by a very simple thing. I just imagine that I'm giving the tokens one at a time, right? Distributed at random. How do I distribute it? Each token, I take it, I am just going to give it to a random, well, I can't say a random player, right? Because if I give it to a random player, then there's a chance that I give everything to player A. So no, that's what I want to avoid. I'm going to think of it as give it to a random slot in this table. Right? There are now these here. So when I first want to give the red tokens, it's like 4 out of 12, 3 out of 11, 2 out of 10, for me to give, let's say, something in this column to all of these. Then I do the same for the white ones. It's 4 of 9, 3 of 8, to fill up 2 of these, let's say this and this. And then the last one is 1 blue goes to player C, that is just going to be 4 out of 7. That's it. So if you were to calculate this, fast forward the process, you get 4 over 385. By the way I calculate this is normally just like this. Just cancel, 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 over and over again. That's what the calculation will be for fractions. Just keep cancelling when there's a lot of these probabilities. Okay, so good thing is that it is pretty unlikely that you will make a careless mistake, because if you had a different approach that is wrong, you're not going to get any of these options most likely. So the good thing is that when we have these sorts of answer options, there is a good chance it acts as a check for us. But of course, the risk is if you had something like 2 over 385. So just check your calculations to make sure that you don't mess up, in case you end up in here and you don't know whether you have got it right. Logic is probably fine for you to end up in here, but calculation is where you need to watch. Okay. 15. Now the numbers of each row and each column form an arithmetic progression of length 5. Arithmetic progression meaning just a common difference. I'm going to put them in, not as like call this x and then try to solve for x, because I don't know what equation to put. And each row and column may have a different common difference. So I don't think I want to give so many names either. What I'm going to do is I'm just going to pick, starting from 0, because 0 is nice. I'm just going to let this be, let's say, D, 2D, 3D, and 4D, right? D for difference. D could be positive or negative, I don't even know. I should be able to solve for D. The way that I'm going to solve for D is very simple. I am just going to use the 3 rows here that I have got one other number. I can get the common difference and just use that to fill up some parts of the row. The most efficient way to do that is to use the first column. This difference and this difference are the same. You get 32 minus t. This difference, you just have 3 times of it. So 48 minus 3d times 3 plus 48. Then I can say that 12 should be the average of those two. That's what would happen. And if you solve this, you are just going to get d equals to 20. D equals to 20 And also very anticlimactically, that just means that this whole column is 12, 12, 12, 12, 12. This thing here would be 80. So when I use the first row, difference is 68. Divide by 4 is 17. So 12 plus 17 is 29. Okay, so time check. With 15 questions down, we have taken slightly less than 30 minutes. This is about the pace that you need to keep if you would like to finish the entire paper. You need to be able to do the later questions, but you also need enough time for them. And 30 minutes for 15 questions is about your goal if you want to complete. If you want to get a distinction, you could take up to 1 hour for 15 questions because sometimes 15 questions is already enough if you're all right. And then in the last 15 minutes, you just do 2 more questions or 3 more questions and you will be safe. So very different targets. For AIME qualification, if you can do most of the first 15 questions, you are safe. For distinction, 1 hour for the first 15 questions is fine if most are correct, and then you do a couple later. If you're aiming to finish, 30 minutes, like what we have. Let's continue on with the fast pace. The roots here are PQR. What is this value? You can Vieta it to death, but there is a common trick that I want you to be aware of. Firstly, where does Vietas come from? It comes from the fact that you can factor this into x minus p, x minus q, x minus r. That's what it means to have these as roots. Second thing, whenever I see squares like this, I am going to factor them using complex numbers. We are in the AMC12 territory here, so we are perfectly entitled to use complex numbers. And each of them can be factored via a difference of squares because, yeah, 2i squared is negative 4. Now you then realize that, oh, so therefore, if I have got this thing here, let's just flip it around. It's negative of p minus x, q minus x, r minus x. I can just let x be 2i and let x be negative 2i in order to make this happen. 2 minuses will cancel out. So put it in. You get minus 10i minus 5. If you put x equals to minus 2i, you should get the conjugate of it. You can check that it is positive 10i minus 5. And so when I multiply these together, I get minus 5 squared minus 10i squared by a difference of squares, and this is going to be positive 125. For each of these cases, remember, look for the fastest approach. If you do not know a faster approach, then of course feel free to use the default. But don't assume that the only way to do it is expand all of it and then use a lot of vietas. That may not be the best choice. Question 17. This is not that complicated as you might fear. It sounds weird. So it's saying that on top of this card, you are going to just place another rectangle card of the same dimensions such that the diagonals line up. Keep doing this, rotating clockwise. I'm not going to keep on doing that. All I'm going to say is that this is the center, right? The center doesn't change, so it's really just pivoting around. Now, all I need to do is to know what angle this has been rotated by. What angle has this been rotated by? is essentially what is this angle. Now, please don't trust that the diagram is to scale. It is really not to scale because 2 plus root 3 is about 3.7, and this is definitely not more than, like, this just looks around double of AB. So don't get deceived by this and say it looks like 60 degrees. It is not to scale. What I would do is very simple. I just will recognize that tangent inverse of 2 plus root 3 is 75 degrees. It's common enough value that you should know that, which tells you that this is 75 degrees, and if this is 75, then this is 30 degrees. Since this is 30-degree rotations, I'm asking how long will it take for something to land up on B. It's not 360 divided by 30 because as long as I'm able to rotate 180 degrees, I am already going to land up there. Right? So I don't need to do that. I just need the next vertex to arrive there. And the next vertex will arrive there. Therefore, when I take 180 divided by 30 is 6 of them. Then I'm going to end up there. Don't avoid trigo. Trigo is very much a part of the AMC12. It's one of the clear differences between the AMC10 and AMC12. Question 18. Cyclic quadrilateral ABCD. Well, that's another difference. Circle geometry is part of the AMC12. I've got CDA is 120 degrees. Okay, I like to always think about this because when something is 120 degrees, here, and then I know that this is in this way, I can draw this first. Don't draw it in the order A, B, C, D. When I look at the angle, I'm like, okay, do I know things around the angle? If I can, put that down first. Okay, so this is also 3, but this is the 120 degrees. So I'm asked, what is the length of the shorter diagonal of ABCD? I guess that it is potentially this thing. I can't really be sure, but then I look at it and say, yeah, I think it's probably the other one that is shorter. Never mind, I'll just use the cosine rule and get this first. Cosine 120 degrees is minus half, and so pretty nicely 9 plus 25 plus 15 is 49, so that is just 7. Okay, so I get 7 here. That's not an option, and all of the options are less than 7. Okay, so I have that. What else do I then have? I know that because this is a cyclic quadrilateral, this is 60 degrees. So I can just use the sine rule to get AB. Right? Actually, no, not AB immediately. The sine rule to get this angle first, and then that could give me AB. Sine theta is 3 over 7 of sine 60 degrees, which is 3 root 3 over 40. Now, because these are equal, I know from my circle geometry that this same angle theta is actually down here, it is also down here, and it's also down here. And so therefore, once I have this, I can actually just use well, any trigo I want on this triangle here, because that same theta, I already know sine theta is this. I'm just going to use it as an isosceles triangle. My preferred option is to split it in half. If this is 3 root 3 over 14, and I want to get this portion, I will just take cosine is 1 minus sine squared. You will find that this is 13 over 14. So this would just be 3 times 13 over 14, and BD, 2 times of this, is 39 over 7. I keep jumping around because I feel like actually I can find everything. They have given you the fact that it's cyclic, which means that you have a lot of options. That would even include, let's say, the extended sine rule at some point. So you have a lot of options. I've just picked the one that only uses the cosine rule and the sine rule and the right angled trigo, so it is as basic as we can. Plus, of course, the property that your cyclic quadrilaterals possess for angles. First word of the question I see is integers. I see the word integers, and it immediately tells me that I am going to not try to solve this as algebra. I will solve this as a Diophantine equation, as number theory. Right, I'm going to try to solve this as number theory, meaning that I will take the difference of two of these and try to factorize it. And if you try to do that, you will succeed. 13 is prime, so all the better. It doesn't say positive, so we don't need them all to be positive. Therefore, there are technically 4 options. One way that we can potentially check this is that alongside the subtraction, I can also do addition. Because if you can factor it that way, then no reason why I cannot also factor it this way. And so what I'll do is just check whether the b plus 1 is a factor of 187. So that may be a good test to do. Okay, so for each of these cases, I'll just write down the values of b. B plus 1. Okay, so immediately I know that I can rule out this one, and I can rule out this one. It's one of the negative cases. If I divide it back again, then I will get a plus c is either 187 here or negative 17. And it does feel pretty unlikely that it's just b equals to 0, right? Because if b is 0, that means c times a is 60, and that's definitely not going to come from here. Okay, so I'm certain that it is this block here, where b is minus 12. To get a, I just take this plus this over 2. And then that's minus 9, c is minus 8, and then I just substitute back in to find this. Okay, numerical answer would be 276. Sorry, brief interruption from my colleague that's bringing me some office supplies, classroom supplies. Question 20. This is basically a puzzle question, and I would argue it's probably one of the most interesting questions. It was also the last one of the AMC10A. This is an example of a slider link puzzle where you are drawing a loop and the numbers are basically just saying how many adjacent edges are used. Up to 4, but of course it cannot be just 4 because 4 would just mean you drew one tiny square. How many ways are you able to place the toothpicks? It's just your toothpicks are just the things along the loop. It is quite apparent that if you try to do it randomly, it won't work, and yet the options are pretty large. So whenever you do a question on counting, it asks you how many ways, just start by finding one meaningful way. Perhaps this is a way. But this is not very meaningful, right? That's just like, you can do this and you can do that. Now, humorously enough, you'll realize that there are two options that are two apart. If you just saw that these are the only two ways you can find, you can sort of think that maybe these two are the special ways, and then you just take 1, 4, 4. Probably this one plus 2 is how you get this answer. And this, my friends, is how some of your fellow students often can guess very successfully. It's the correct answer. But I'm not going to leave you there. We are going to explain why. So I want to find one other type of example, right? And the other type of example could be, for instance, if I don't want to be all on top, I need to sort of cross the river, right? If you imagine these ones are the river, you need to cross the river somewhere. Now, if I cross the river down here, I can't draw a loop, because if I draw the loop here, I've left out these guys. If I draw the loop down here, I've left out these guys. So I cannot cross the river there in the middle. I can cross the river here because this is satisfied. I can also cross the river just at the boundary. When I cross the river means I need to cross back on the other end. So these are my two different types of options, which I will just call A and B. A on the boundaries and B slightly inner. Okay, so if we have got A and A, it means that you do this. These are satisfied. All these guys are not satisfied, and the way to satisfy them is either above or below. Now, if you were to do something random like this, you realize that, yeah, there is a way to draw it. If I demand it to be this few, there is always going to be exactly one way that you can draw the path to make this happen. Right? You can also say that I want it to be like that. Also can. You just follow along the path on top and follow along the path below. So therefore, for AA, meaning that you use those two edges to cross the river, these middle 6, you either decide to use the top or the bottom. That's 2 to the power of 6. You can see the same logic applies if I use AB and BA, or if I use BB, there will just be fewer to pick from, because if I use B, then 2 of them are satisfied instead of 1 being satisfied. So 2 of 2 to the 5 and 1 of 2 to the 4 will add up to 144. And then we plus 2 for the neither, because you don't cross the river at all at A or B, you just float on top or you sink below. So that is how you end up that the answer is really 146. Okay, 21. Straight away, I see this is an estimation question for area. Right? I don't have to find it exactly. I'm choosing them uniformly and randomly on the sides of equilateral triangle ABC. Now, P and Q, the area of this being half just depends on, let's say, if I call this X and Y, it's just the probability that XY is at most half or less than half. If I just need the probability that XY is less than half, where my X is randomly chosen on this side, meaning between 0 and 1, whenever there is a range, draw a graph to represent the probabilities. So 0 to 1, 0 to 1, and X times Y equals to 1 half is going to be just this bit down here. That is, wait a second. No, that's not right. This bit down here, sorry. So this is the point half 1 and the point 1 half, right? So this is going to be how your graph will look like. And everything here is going to be included, which is clearly more than 3/4, but less than 7/8. So if you were to just extend the graph, what I'm saying is that the graph of xy is equal to half is going to actually extend like this, right? This is the graph, but we are only taking the slice from 0 to 1 in order to find out which portion I care about. So in the end, only this tiny portion, so we can get an estimate well enough. By the way, please don't skip all the last few questions and assume they're too hard, even if you are not aiming for a DHR. Sometimes there may be some easy ones behind. Okay. Question 22. This is a very weird looking way of writing the recurrence. Why do they have to write it like this? I don't know. It seems like they're trying to make it look a bit catchy. I'm going to just rearrange this straight away because if you are looking at this here, I don't feel like calculating the next few terms even in this way, right? If I wanted to calculate the next few terms, I would definitely not calculate the terms in this form. Instead, once I write it like this, well, that's a lot better. I noticed this interesting feature, which is that, well, if you don't notice it, let's put in the numbers and you will see. So n equals to 2, n equals to 3, and so on, will basically tell you that, well, I knew A1 is 2, so 2A2 is 5, 3A3 is 10, 4A4 is 17, and these are just squares plus 1. That's because the squares are formed by the sum of odd numbers. So except that I didn't start at 1, I started at 2, so everything is 1 more than a square number. That means that my an, or the nan, is n squared plus 1, and an is n plus 1 over n. I found the sequence. I can now, what do I want to do? I want to square it. I can square it. And if I were to square it, I would expect that it's quite nice. Okay, so this is what I get. And now I'm supposed to add from 1 to 100. Okay, so firstly, if I add n squared from 1 squared to 100 squared, that's the first contribution we want to use our sum of squares formula. And this is also a number that you will see quite often, sum of 1 squared to 100 squared, just like the sum from 1 to 100 is 5050. There's also another contribution of 100 tools. So you can see that, oh, yeah, that's why all the options are like this. I need to estimate 1 over n squared when I add that. Now I'm going to claim that this is just between 1 and 2. The reason why this is between 1 and 2 is that it's clearly more than 1. But if you take this tail, it is smaller than if you were to write it as our familiar telescoping sum, which is still going to be less than 1, even when I have actually made all the denominators smaller. So if that tail is less than 1, then the whole thing is less than 2. So therefore, my sum is going to be 338550 plus 1 point something. And the question asked me to round up. Option B. Okay, 23. What is the value of this thing? I don't think that this is as messy as it looks. Perhaps radians are concealing it a bit, but you know that these here sum to pi over 2, 90 degrees if you will, and we know that tangent pi over 2 minus theta is just 1 over tangent theta. So therefore these two also pair up, meaning that I can actually just let x be tangent pi over 16, y is tangent 3 pi over 16, and this would be 1 over y, this would be 1 over x. And this is therefore what you actually get. Okay, now I'm not going to calculate it yet until I have to, because I see that this can be factored. And so I'm sure that tangent pi over 16 is not that special an angle, but maybe it works well if I calculate this. So let's just check, what does tangent squared plus 1 over tangent squared actually simplify to, and maybe good things happen. There are so many random trigo identities that I'm always prepared for something nice to happen. I'll convert everything to sines and cosines where I have got more info available to me. And this is actually pretty typical, that when you see all the even powers, you can say that, okay, this sine squared times cosine squared, 2 sine theta cosine theta is sine 2 theta. So this we'll just put it as 4 over the sine squared 2 theta minus 2. remember our goal? Our goal is that we are trying to calculate this. So twice of this angle is a bit better, but I can do even better by using my cosine double angle formula to further simplify this to something where I can actually calculate, because 8 times of those angles, I really like that. 4 times of those angles, I also like that. 2 times, not quite enough. Okay, so this is now the most simplified form. Okay, so back to my x squared plus 1 over x squared. My angle was pi over 16. 4 times of that is now this. 4 times of 3 pi over 16. Now both of these are nice. Okay, cosine pi over 4 is root 2 over 2. Cosine 3 pi over 4 is negative root 2 over 2. I think I can just fast forward a little bit of the algebra. These will be conjugate, so you can expect the simplification to be the same. So 14 plus 8 root 2. This one here, you end up with just this being minus. So it's 14 minus 8 root 2. And then you multiply them together to get our final answer. That would be equal to 68. There's this sense of the questions behind taking exponentially more time, right? So meaning that you should not like expect that there is a 2 or 3 line solution for all the questions behind. There may be sometimes, but occasionally they're just bash. They just have a lot of work to do. And therefore, if you have like 3 minutes left, I think you should not go and try to do a question unless you have checked everything in front. If not, just go back and check that 1 or 2 questions that you told yourself, I'm not so sure of this one. That's a better use of your time towards the end. Okay, now 24. A disphenoid. What's a disphenoid? Well, they tell you a tetrahedron whose triangular faces are congruent to one another. Basically, this is not that complicated. It's just saying that you have got, I mean, this is a tetrahedron, right? Four triangular faces, and effectively, I'm saying that there are 3 different lengths that each appear 2 times. If you have 3 different lengths that each appear 2 times, then all the 4 triangular faces are congruent to each other. This is the only way it can happen, right? They must have the same side lengths. They ask you for the least total surface area. So the smallest possible area of one of these faces times 4. And the faces are scalene triangles with integer side lengths. Okay, now here's the deal. We must have some geometric condition for which triangles, all right? Not all of these triangles, it is possible to so-called fold them up into this. I mean, you could have 4 copies, but I may not always be able to make them all come together. The condition, which honestly, if you don't know this and if you don't guess this, there is just not enough time to work it out, is that it works as long as they are acute triangles. This is not that hard to imagine if we're being perfectly honest, but they must be acute triangles is the condition for this to work. Any acute triangles are fine. I'll leave it as an algebra exercise for you to show if you have not seen this before. But for everyone else, what it means is that your area of each side, you want to have a small scalene triangle. I'm going to just let these be A, B, and C. In fact, I'll let it be A less than B less than C since they are scalene triangles. And now if I said that they are acute triangles, it means A squared plus B squared is more than C squared. This is what acute means. Now the area, if I use just half AB sine C as a reference point, it means that for any choice of A and B, I should make my C, right? So sine C is going to be maximized, going to be minimized if your cosine C is maximized. Cosine C by my cosine rule is this thing. And so therefore, once I've chosen A and B, I should try to make C just as small as possible for any given choice of A and B. Which could be just B plus 1. Now, if C is B plus 1, and I also want A and B to be small, I can just check all the smallest cases. The difference of squares here, how is it going to work? Right? So if let's say A equals to 1, clearly that doesn't work. Because A squared, based on my choice, is like this. If A is 1, that fails. If A is 2, I need B is 1, which then doesn't work. If A is 3, then B can be 3, also doesn't work. So if A is 4, B can be 5. And C can be 6. That works. So a 4, 5, 6 triangle, just one step beyond my 3, 4, 5 triangle, is sort of the smallest scalene triangle I can make in terms of area. Okay, so in that case, once I've chosen these sides, the easiest way to get the area, I think, is we can use Heron's formula. Your semi-perimeter is A plus B plus C over 2. So S, S minus A, S minus B, S minus C. Great, this is one of the options, so gives us a sense that we haven't actually messed up. Yeah, so basically, if you had tried to do it with let's say a triangle with side lengths 2, 3, and 4, you will of course get a smaller triangle, but that does not close up into this disphenoid. So that is the acute triangle is the condition which is sort of restricting you from just picking small side lengths. Okay, last question, and I'm looking at the time. We have basically, if you want to finish, just over 5 minutes. And this is something that, to be honest, it takes more than 5 minutes. Well, I did spend a lot of time talking about stuff, so we'll just extend slightly beyond that 5 minutes. How many quadruples of A, B, C, D integers where these are all less than or equals to 5, C and D are not both 0, is this graph symmetric over y equals to x? There's only one bit of like actual graph work here, which is that when something is symmetric over the line y equals to x, it just means that it is its own inverse. It's its own inverse, meaning that if I were to call this thing f of x, fx equals to f inverse x, or more simply, ffx equals to x. So we will just do the very boring thing of calculating ffx. Okay, so this is my fraction. I am going to multiply top and bottom by cx plus d. Okay, so this is supposed to be equal to x, meaning that if I multiply over and I just group by coefficients, a squared plus bcx plus ab plus bd is on the left, and on the right I get ac plus cd x squared and bc plus d squared times x. Okay, so this is supposed to be true for all x, meaning I can compare coefficients and say that AC plus CD is 0, AB plus BD is 0, and A squared plus BC equals to BC plus D squared, which of course just means A squared equals to D squared. Now this is interesting though, because this tells me C is 0 or A plus D equals to 0. This one tells me B is 0 or A plus D equals to 0. This tells me A equals to D or A equals to minus D, which is the same thing as that. Okay, so one thing that I also will need to ensure is that these are not 0 over 0. So because I need to make sure that these are not 0 over 0, we may need to check something at the end, because I'm saying that this portion is 0. So this should not be 0. Otherwise, there is nothing left in this denominator. And so that I'm also going to keep track of. I'm not sure if I need to keep track of it, to be fair. We shall check later whether it actually matters. Okay, so what are the list of things to worry about? First of all, if one of them, A and D, is 0, the other is also 0, the both cases collapse to the same thing. Then, okay, so B and C cannot both be 0. B and C can be anything else from minus 5 to 5, but I exclude B and C being 0, that gives me 100 cases, 10 squared. Now, if my A and D are both non-zero, but they are equal, so I should just write it. If A and D are equal and non-zero, then I need B and C to be both 0. So if B and C are both 0, then A and D this time are the same. There are 10 choices for A and D. Now, if A and D are both not 0, they are just negatives of each other, then my B and C can be anything. So I've got 10 and 11 choices each for B and C, 10 choices for A and the corresponding negative D. So this is my next case. I have already gotten into the territory of here, but I need to subtract off stuff. I need to subtract off stuff where BC plus D squared equals to 0. And if I need to subtract off cases where BC plus D squared are equal to 0, sorry, we just kind of need to check cases. D equals to 1, then BC equals to 1 minus 1, or vice versa. Every time there's always the reverse ones. If D is 2, you have got 1 minus 4, 2 minus 2, 4 minus 1, and vice versa. D equals to 3, 4, and 5 thankfully only give you just this and vice versa. Okay, so a total of 7 times 2, which is 14 pairs to remove from what we had earlier. And also, of course, D is plus or minus as well. So when you finally subtract off all of these, you get 1292. And that is the AMC12 paper. As you can see, it scales up pretty much to the end. Not in terms of difficulty, honestly, this is just very mistake prone. At the end of this, make your own judgment as to what is a reasonable target to make, because as I said at the start, that is going to have a huge impact on how quickly you move. And also, just remember to take note of your own kinds of careless mistakes that you will tend to make. Try to avoid them and also go at the pace where you minimize your own sets of silly mistakes. Okay, so this just took a touch over 1 hour 15 minutes. Not too bad. Feel free to let me know if you have any other questions about the solutions. And also the videos for the AMC10A and then the 10B and 12B will be available for you to check out as well. Okay, so thanks for watching and all the best.